Imagine a grand assembly choreographed by countless stars, planets, moons, and wandering satellites. An endless performance of cosmic rhythm stretches across the heavens, an eternal harmony so vast that human thought can scarcely contain it. Every celestial body contributes its own note, forming a symphony of light, gravity, and motion. Yet within this orchestra of creation, one section captures both scientific attention and human wonder. The exoplanets. Exoplanets are distant worlds circling stars far beyond our own Sun. They lie hidden in the immense reaches of the galaxy, cloaked in cosmic shadows, yet their presence is undeniable. Some echo Earth's familiar landscapes, as if they were distant reflections of our world, similar, yet deeply alien. And among these countless possibilities, one planet has risen again and again in both research and imagination: Proxima Centauri b. Only 4.2 light-years away, cosmically speaking, in our own neighborhood, Proxima b has the potential to change how we think about habitability itself. In a universe that stretches nearly 93 billion light-years across, stumbling upon a potentially life-supporting planet so close is like discovering a shining jewel hidden within a mountain of stone. Astronomers estimate that the Milky Way alone may hold more than a quadrillion exoplanets. That's a 1 followed by 15 zeros. To picture it, imagine shrinking each one to a single grain of sand. Together, those grains would not just fill the Grand Canyon, they could carve a second Grand Canyon made entirely of possibility. Even more remarkable, perhaps 20% of these worlds could resemble Earth, with landscapes, climates, and atmospheres capable of sustaining life. And orbiting many of them may be moons, each a potential canvas for biology to take hold. For anyone who has ever wondered if we are alone, the cosmos offers not a handful of chances, but an ocean of opportunities. At the forefront of this search stands the James Webb Space Telescope. This engineering marvel, with its golden 6.5-meter segmented mirror, nearly 3 times larger than Hubble's, can detect the faintest glow of stars and the dim silhouettes of planets orbiting them. But Webb is not just a telescope. It is a laboratory in orbit. Armed with advanced instruments and spectrometers, it can split starlight into its finest details, revealing the chemical fingerprints of alien atmospheres. Through these signals, scientists can learn if a distant world holds water, organic molecules, or oxygen, the raw ingredients of life. Since its discovery in 2016, Proxima b has been one of the most captivating targets. Orbiting a dim red star within its habitable zone, it lies in that delicate region where liquid water might exist. Picture its horizons: landscapes sculpted by unfamiliar winds, seas glowing beneath a crimson sky, and days that last 11 times longer than ours. Sunrise would take hours, and twilight could linger endlessly. For humans, living under such cycles would mean redefining how we eat, sleep, and measure time itself. Here, Webb becomes indispensable. By examining the light that filters through Proxima b's atmosphere, it can search for gases like methane, carbon dioxide, or oxygen. It can test whether water vapor rises from alien oceans, or whether conditions resemble those that once nurtured Earth. For the first time, we are no longer simply imagining such worlds. We are reading their skies like open. Then came something wholly unexpected. While astronomers sifted through Webb's observations, a curious anomaly appeared in the data. It was subtle, faint, yet unlike the countless random bursts of cosmic static usually found in such readings. This signal carried structure. It pulsed in a way that felt deliberate, as though it had been arranged rather than born of chance. For a fleeting moment, humanity held its breath. Could this be more than a quirk of nature? Could it be a message? But as quickly as it appeared, it was gone. No echo. No repetition. No second chance. Just silence. Theories rushed in to fill the void. Some scientists argued it must have been interference, perhaps from our own instruments, or a fragment of background radiation masquerading as order. Others suggested it could be a rare natural event, a phenomenon of stellar physics not yet understood. But there remained a haunting possibility, that it was purposeful, and that we had caught only the faintest whisper before it faded forever into the noise of the cosmos. This unresolved enigma lit a spark of ambition. If one fleeting anomaly could stir such questions, what might lie hidden in the night sides of distant worlds? Researchers began to imagine searching for artificial illumination, the glow of alien cities shining faintly across the darkness of their planets. The concept is bold. While stars outshine everything, a telescope as powerful as Webb might one day separate starlight from the dim, steady glow of technology on a planetary surface. If even the faintest trace of such light were found, it could mark the first indirect evidence of intelligent life beyond Earth. And yet, Proxima b is only a single candidate in a vast ocean of worlds. Thousands of exoplanets continue to reveal themselves, many lying within the delicate habitable zones of their stars. Some orbit blazing giants, others quiet red dwarfs. A few may resemble Earth closely, others may be stranger than any landscape we can imagine. There could be worlds with seas of methane instead of water, skies choked with ammonia clouds, or icy shells concealing hidden oceans deep below. Here on Earth, life has shown us again and again just how resilient it can be. In boiling volcanic vents at the ocean's floor, life persists. Beneath Antarctica's crushing glaciers, microbes endure. Even inside radioactive waste, organisms cling to survival. If biology can adapt to such extremes here, what might it achieve under alien suns? The James Webb Space Telescope gives us the tools to test these possibilities. By analyzing the light of distant planets as they pass before their stars, a method known as transit spectroscopy, Webb can decode the chemical composition of their atmospheres. If starlight filters through methane-rich skies, or reflects from oceans of water, Webb will see it. And Webb does not work alone. Artificial intelligence now assists in parsing its colossal streams of data, sifting through countless variables, and recognizing patterns too faint or too complex for the human eye. Together, human curiosity and machine precision form a partnership unlike any in history, one that could bring us to the edge of the most transformative discovery of all time. So the question echoes louder than ever: are we truly alone? Perhaps life, in its endless diversity, is not rare but common, spread across the galaxy like hidden music, each planet playing its own variation of a universal song. Perhaps, even now, civilizations far older than ours look outward from their own skies, asking the very same question. And maybe the answer is already there, carried on faint signals, woven into alien atmospheres, or shining softly on the night sides of distant worlds, waiting for us to listen carefully enough to hear it.